now let's first understand some names which we are going to face many times while discussing anything new. So now we are going to start with the addition and subtraction of polynomials. But let's first understand some very basic names which we are going to face many times while talking about a polynomial. So let's say this is a polynomial. I'm just writing a polynomial. Let's say, so this is an expression. So 2x square plus 3xy minus 7y cube plus 4x square y plus 5 minus 3. So this is a polynomial. We can see that every term has powers of variables which are positive integers and they are simply multiplying. So this is a clean polynomial in two variables. This is a simple polynomial in two variables. So now comes some names which we are going to face many times. First name is actually coefficient of the variable. So in this case we can see that this term x square is a variable. Variable means what? That whatever value of x we'll fill over here, we'll get some corresponding value in the entire expression. Let's say if I fill the value of x as 5 and let's say y be 3. So I would ultimately get some value of this expression. What I will do with it, that's a separate question, but just try to understand that okay, this x is a variable, this x and y are not having any fixed values as such at this moment. So this term is a variable term. So the number, the constant which multiplies with this variable term in front of it, that is known as the coefficient of this variable term. So the coefficient of this term, the coefficient of this term over here is 2. The coefficient of this term, this variable term over here is 3. The coefficient of this expression over here, this y cube over here, is this minus y. I'll also take the minus sign in the coefficient part only. So the coefficient of this y cube, if someone asks me that what is the coefficient of y cube in this expression, I'll tell directly the examiner that the coefficient of this y cube is minus 7. Similarly, the coefficient of this x square y term is 4, this y is 5 and this is constant. The constant at the end is minus 3. So this is the first name. So we should be comfortably knowing this name that okay, the coefficient is actually the constant written in front of the variable term in each term actually. So each term is having a different coefficient. So this is the first name. Next name which we are going to use many times is actually degree. So degree actually means that what is the highest power. We'll first talk about the degree of an expression. Degree of each term, let's say. So this term, just look at this term. What is the power of complete power of the variable in this expression? It is in this case 2. So the degree of this term is actually 2. This is a 2 degree term. Now if we actually go to this term, in this term we can see that two variable terms are multiplying. With one term having a power of 1, which is the exponent 1 over here, and the second term also having a power of 1, which is again the exponent of the second term. So when these two are multiplying, so if someone asks me the degree of this expression, so it would be 2. It would be a 2 degree expression. So this term is a 2 degree term. One of this and one of this we have simply added. Just like multiplication when we do the variable and we simply add the powers. So it is exactly moving in that sense. We can directly say that the degree of this expression is 2. So and now if I move to the third one, the degree of this expression is 3. The degree of this expression is 2 and a 1 here. So this is again a 3 degree expression. Degree of this expression is 1 and degree of the constant term is 0. So this is the term. If someone asks me the degree of the polynomial ultimately, so degree of the polynomial means the highest degree term that is occurring in this polynomial. So in this case, we can see that the highest degree term that is occurring is 3 over here and 3 over here. So we'll call this polynomial a 3 degree polynomial. So this is a polynomial which is a 3 degree polynomial. But if I talk about each expression in general, we can directly judge that, okay, this is a 2 degree term, this is a 2 degree term, this is a 3 degree term, and so on. And interestingly, we can see that these terms are not mixing with each other. This 2x square cannot be directly added to this 3xy. We can't actually come to a solution. It is not actually 2 adding with 3 which makes up 5 directly. This is a separate term because for some value of x square, this would create some other value, and 3xy is a completely different entity. So we are not able to directly add them as such. So we'll write them just like this only. So this term and this term are not, we cannot mix them. These two terms cannot mingle together. So this is again a new name. Now we know that exactly we know that what does a degree of an expression or an entire polynomial means. Just actually remember this basic name. So now comes another name which is very straightforward, and we are going to use it just to actually add or subtract terms, which is like terms actually. So now in order to actually go into this understanding, if I just create one more example, let's say we are given 2x square plus 5xy plus 3y square. This is one term. And someone tells me to add this term to 5x square minus 2xy plus y square. So this term, which we can see that this is a polynomial, is to be added to another polynomial. So when we are adding two polynomials, so just keep this basic understanding in your mind that we can, if we have to simplify this expression, I can only mix like terms. I don't have any other option because this 2x square cannot add directly with this 5xy without actually filling the value of x and y. And we don't know the value of x and y because these two are variables. So if we have to simplify this expression, just think of this x square as an apple. This xy, let's say, is an orange, and this y square is some other fruit. Let's say it's a banana. So they just actually look at this term. So in a way, there are 2 apples over here, and in this expression there are 5 apples. So these 2 apples can be added with these 5 apples because over here we are having 2x square. If someone asks us that how many x squares are there, we can directly say that there are 2x square in this term, and similarly there are 5x squares over there. So how many x squares are there in all? We can directly say that 2 plus 5, there are total 7x squares. So in our way, there are 2 apples over here and 5 apples over there. So we can directly say that there are 7 apples. 2 plus 5, 7. Now comes the next term. So there are 5 oranges over here, and over there are minus 2 oranges. So 5 oranges minus 2 oranges gives us 3 oranges. So 3xy. So 3y square here similarly and a y square there. So this makes up the term as 4y square. So this is the way we add terms, and we add only like terms. So this term and this term were like terms, exactly the same term, but with a different coefficient. So we can directly add and subtract those coefficients. If I directly think of those coefficients as simple numbers, let's say as we just discussed that there are 2 apples placed over here and 5 apples in a way over there, where I am calling this x square. I'm just taking this x square as a simple apple. So 2 apples plus 5 apples makes it together as 7 apples. This would be 7x square plus 3xy plus 4y square. And exactly same is the way of subtracting them.